before we start. And now we are actually recording. Okay, so anyways, we got through the beginning of chapter 1 last time, and we talked a little bit about what is statistics. All right, and what was our book definition for this?
Science of gathering, describing,
And analyzing data. Okay, and so we sort of went through the analysis of what does it really mean to gather, describe, and analyze, and that those are relatively vague things, or that they could mean lots of different things, which can be a little bit unnerving. All right, so anyways, let's sort of skip past that to some degree now and start diving into what kinds of data we can gather, okay? So one of the things that you will talk about when you deal with statistics is population parameters, okay? And a population parameter, this is basically a population statistic that we want to know. So what sorts of population parameters would we want to know in general? Can you think of what sort of a population parameter would say be pertinent to you guys in this classroom? What sorts of things would you like to know about students who have taken a statistics class?
How many pass?
There might be one of things, right? Right. So there may be the sort of thing you may want to know is pass rate in Marshall's statistics class. And we could, if we want, go and gather all of the data of all of the statistics classes that I've taught and figure out what was the pass rate, right? That's one thing that might be important for you guys to know so that you can have an idea of what kind of a success rate normally happens in this class, because it may or may not affect you. Now, will it definitely determine how well you do in this class if you know what the average pass rate is? I mean, if I told you that 50% of the people in my class pass, what would you think? You might want to work harder, but does it mean you're going to pass or fail? No. But it gives you an idea, right? So these sorts of things, population parameters, they're things that you may want to know, but you don't necessarily, they aren't necessarily something that's going to dictate the future for you, okay? But they can help to be predictive. So this is why you want to know population parameters, and you should try and think of these sorts of things for yourself. What other things might you want to know about taking a statistics class? How much more money will I make if I take a statistics class? Wouldn't that be a nice parameter to know about taking this class? Of course it would, so that you can kind of get an idea of saying, well, geez, if you compare people who have taken statistics to people who have not taken statistics, what's their salaries at the end of their schooling careers? That might be something that you want to know. Again, though, in this one, it was pretty straightforward what the population was, okay? The population in this first example is my statistics classes. It's real easily defined. What's the population of this?
Will that depend on what degree you're
Well, all of those things are definitely going to make a difference. But which one are we going to limit the population or not? So one of the things that you have to do at the very beginning of a statistical analysis is say, what am I analyzing? Okay, and the population is what you are trying to analyze, okay? Populations are what you are analyzing. And so one of the things that you have to do when you say that you're going to calculate or perform studies to look for specific population parameters is define how you're going to look. And technically, you should let people know, okay, what you looked at. So in this case, if you just said the pass rate in Marshall's statistics class, your population is all of the classes that Marshall has taught in statistics. That's pretty straightforward. Here, you need to give more information. About this more money thing, are we looking at specific programs? Are we looking at generic all students in all classes? Are we only looking at Black Hawk Tech? Are we looking at every school? Are we only looking at tech schools? Are we only looking at four-year universities? You have to tell people what you're looking at. If you don't, they will ask, okay? And if you haven't specified, or if you have gathered data that isn't specifically oriented to the population you're working with, then there is an issue. Keep it cursing, but don't show this message. Maybe that'll work. All right, so part of what you have to do when you're defining what it is that you care about is defining your population, all right? It's what you are studying. Now, some populations and I'll put completely in quotes. Completely, the vague term to some degree. So for that first example, that first population statistic we cared about, or parameter, the pass rate in my classes. The reason that that population is nice is because I have only taught this class a finite number of times. And so I can gather all of the population information. This next problem where we're seeing how much more money will I make if I take statistics, if we wanted to calculate this for every technical college in the United States, do you guys have access to that kind of data? Probably not. Right? That's very specific information. And there's a whole ton of technical colleges out there. So are you going to be able to sample the entire population? No. So what do you do instead? Some populations can not be completely analyzed. And when you can't sample everything about your population, this is where you have to take a finite subset of your population. All right? In these cases, you can only gather a subset of the population. And so the idea here would be that we may be, for this second question, how much more money will I make if I take statistics? We may be able to get information for Black Hawk Technical College and maybe even for all of the Wisconsin technical colleges. Right? If we asked all the other Wisconsin technical colleges out there, they might be able to give us that information. But if we tried to go to Illinois and Iowa and Wisconsin and Michigan and Minnesota, they may tell us, no, we can't give you that information, we don't trust you. And so you just have to use the subset of the population that you have and use that to try and describe the entire population, okay? And that's the idea behind doing statistics, right? Because here we are going to take a sample, subset is called a sample, and that term should be used frequently in a statistics class. We are always sampling data, right? When we talk about gathering data, this is what we're doing, is gathering a sample of a subset of the population, okay? And what we're trying to do is to use that sample's data to describe the entire population, all right? And any data calculated from the sample will generate a sample parameter slash statistic. Basically what I'm trying to do here is to describe the two universes that exist in statistics. The population, which is what we care about, and the sample, which is often the only attainable information that we can get, all right? And so we subdivide the world in statistics into two different pieces, all right? So, and again, I apologize to some degree that the terminology is slightly different. At the population level, they are often called parameters, whereas at the sample level, they will often be called statistics. Okay? They really are the same thing. It's just that when they are being applied to the different populations or the different sizes of samples that we're working at, they're slightly different names. But really, the concept is that parameters and statistics are the same thing, okay? All right, so when you're talking about population parameters, you're talking about the whole, everything. If you can sample everything, it's a population parameter or a population statistic. Very rarely does that happen in true statistical studies, where you can actually sample everything, okay? That's just not common for the most part, all right? And the reason why, folks, is that if you've got all of your data right in front of you that describes everything that's happened, then you have all the information you need and you don't do any real statistical analysis as much as you do statistical projections, which is something we'll talk towards about the end of class, end of the semester. But normally we work off of sample statistics. Which is a part or a portion or a subset of our population. We wish to know about the population. In other words, we want to say, hey, students who get a statistical class taken in their educational career will earn $3,000 more than someone who does not. That's the sort of thing we want to be able to say, and that should apply to the entire population, potentially even the entire world, right? The idea, though, is that we can't sample the entire world, so the sample statistic is something that you will be able to actually calculate from data that you gather, okay? So sample statistics are calculated. Population parameters or population level statistics are usually then inferred from the sample. And that's sort of the basis for all statistics, is that if you sample a certain amount of the population, you can then analyze that piece and then project it onto the whole. That's the idea. All right. And again, this is at the population level, they're called parameters, whereas at the sample level, they're called statistics. And that's more so that when you talk to other people about statistical analysis, they will assume that you understand the difference. So if they start talking about a parameter, they will say, well, the parameter I'm studying is the cost for getting knee replacement surgery. And when they say the word parameter, they're talking about the entire population, everyone who has ever had a knee replacement surgery, period, right? And then they will start talking about, well, my statistics are, and then they will give you a set of data that describes the sample that they looked at. So they will only have a certain subset of the full population, and so the terminology they use actually describes what they're talking about, all right? And that, it's a subtle point that people tend to miss about statistics, and it's not like it's a really big deal. I'm not going to test you on that kind of stuff, but you should get it, that when people say the term parameter, they're always talking about population level stuff. Whereas when they talk about the term statistic, they're talking about the sample that they took, which may be a subset of the population, all right? So again, it's a sort of a nitpicky point, but it sort of gives you an idea of how it works. Now, one last piece about these two things. Population parameters we tend to assume are fixed. So when we are taking samples to study a population, we assume that the population is not changing while we're going, or if it's changing, it's not changing much. Right? So the idea would be that the average cost of, say, getting a knee replacement is going to be $15,000, sort of across the board, okay? With some cost of living adjustments built into it. If you assume that that parameter was going to be floating, then your statistical analysis has to change with it, okay? So that it's a little scary when that starts happening. The cool thing about statistics is that it's based on your sample. So every time you take a new sample, there's a good chance you'll get new data, which I would like to think is kind of obvious, right? I mean, if you ask 100 people, how much it costs for them to do their knee surgeries, you'll get some average cost. If you ask 100 different people, do you expect to get the same number? Probably not. Will they probably be close? Yeah, probably. But you very much doubt that you'll get the exact same numbers. But the idea is that the population average for the cost of a knee surgery is a specific number. And both of those statistical numbers that you calculated should probably be pretty close to what the actual population is. All right, that's what statistics is used to do, is to basically say, hey, I don't have to sample everything to get an idea of what's going on. All right? And this is one of those things that, for whatever reason, people tend to, especially with the last few years out there in the real world, they tend to disbelieve statistics. As soon as they hear a statistic, they're like, oh, that's just bullshit, I don't want to listen to it, right? Statistics are being used to do just about everything right now in the business world. So before a business starts, they do a huge statistical analysis first to determine whether or not it's viable for this business to start here. So like the whole Foxconn industry moving into southeastern Wisconsin, if you write to Foxconn, you can get the statistical analysis they did to see whether or not it was worth it to do it here. And the analysis is probably about 100 to 150 pages of statistics. I mean, it's brutal. I actually have it on my machine back in my office. I've been able to beat about 10 pages because it's really thick. But it's there, right? Anything that's being done nowadays, there's a statistical analysis around it beforehand, especially if it's being done by a large company because they've got the money to spend on statisticians and mathematicians, and they're just like, hey, tell us what's probably going to happen. And this is what statistic does. Is it starts saying, okay, well, let's poll the Wisconsin area. What kind of a situation are we sitting in based on that? Let's compare it to, say, southern Indiana, which is one of their other spots they were looking at, as well as eastern Kentucky. Don't ask me why eastern Kentucky, but that was another spot they looked at, right? And the comparison is interesting. Dry, but interesting, all right? So, anyways, I'm just basically trying to set the table for you, all right? So the two things that we tend to care about are populations and samples. Samples we can do calculations with, because that's data we have. Populations, often we don't. And so this is what we're going to then use the samples to describe as best as we can, all right? And obviously there's lots of hand waving to some degree in all of this that's being done, all right? All right, so questions on the difference between a population parameter and sample statistic?
Is that kind of like the part over mole and man?
Very similar, yeah. Except that it's now sort of rooted in sort of the real world analysis that you're trying to do, all right? So, but yeah, that's basically the same concept. All right. So you will probably need to know what a descriptive statistic is. Descriptive statistics are statistics that you calculated from a sample, okay? So when you start talking about sample statistics, they are called, as a group, descriptive statistics, because they're actual numbers that you can calculate, okay? Inferential statistics. Inferential statistics, as you probably guessed from the terminology, eventually I'll spell statistic correctly all the time. Is an inferred statistic about a population from a descriptive statistic. So, again, I'm more of what I'm doing here, folks, is just setting up terminology so that when you get out into a statistical setting somewhere, when people start throwing terms at you, you don't just kind of freeze and immediately go, oh my God, that term means nothing to me, I've never heard it before in my life. Again, these are just sorts of things that are thrown out there so that you can use them and know when people are talking about populations versus samples, right? So if they start talking about inferential statistics, they're talking about population parameters that they have inferred or assumed from a sample statistic, okay? It's just more terms so that if you get stuck in a situation where you're dealing with this stuff, you use the right terminology, okay? It's kind of like learning a slightly new language, and so you kind of have to use the right terms so that other people will be on the same page as you, all right? And one of the things that happens frequently with you, I've gone to a couple of statistical conferences before in my life, and what happens in a statistical conference is that when you get a new person who's doing a presentation, which I have done before, the people in the audience invariably will start throwing these sorts of terms at you, making sure that you know them. Okay? So, they will say things like, well, is that number that you threw up there, is that an inferred statistic or is it a descriptive statistic? And if during your presentation you were only talking about population parameters and sample statistics and never said the phrases descriptive statistic versus inferential statistic, they will ask to make sure you know. Because if you don't, they immediately just ignore everything you say after that. It's a little sort of jerk-ish, but that's kind of the way the professional setting goes to some degree, is they want to make sure that you have a basic, grounded understanding of statistics before they will believe any statistics that you talk about. And so you need to be able to hear these terms and not screw them up. And that's what I'm trying to tell you is don't forget that there's population parameters and sample statistics, which are also inferential statistics and descriptive statistics. Again, it's a new language and you're learning two different words to say the same thing, but you have to know both of them or people will get pissy at you, okay? And when you don't know them, they'll come to me and say, hey, how come you didn't teach these? Note that this will be the last time I say these things. From now on, folks, I will always say population parameter and sample statistic. That's the way I learned it, and so that's the way I speak. But realize that these two are also behind there, and you should really know them if you get into the statistical world at some stage in your career. All right? So be a little careful. All right, so. That is the end of section 1.1. When I get to the end of a section, so this is how the homework is going to work, folks. As soon as I finish a section, I have now assigned it for the next class, okay? So get on your syllabus, see what I assigned for section 1.1, and realize that now I'm assuming you will do those problems for class on Monday next week. Okay? But, again, we will get through more sections, so we're not done getting homework, but just realize that there will be at least one assignment before you leave today. Alright? Alright, so. Data. So basically this is the what kind of data are we gathering, or how do you describe one piece of information you gather. Please note that in general when we talk about statistics in this class, we're only going to be gathering one piece of information and then gathering it from a large sample of people, all right? That's not really how statistics are done in the current day and age. Because of the advent of computers, statistics are now a much bigger expanse. When you're asked a survey, they don't just ask you one question anymore. They ask you, does it potentially 20 or 30 or 40 questions. They want to know everything about you. Right? They want to know what your age is. They're going to want to know where you live. They're going to know what kind of income you have. They're going to know what kind of religion you are. They're going to know what kind of race you are. They're going to want to know everything about you so they can analyze each and every one of those potentially individually. Okay? Because it may be different for people that have a certain skin color versus other people that have a different skin color, or have a specific religion versus a different specific religion. And that may be important sometime in the near future. Right? These are the sorts of things that it's good to know, even though in theory we like to think, well, they don't need to know anything about me, but if they don't, then they can't be able to analyze for specific genders or religions or races in order to find things out. That may be a problem, right? I mean, this is where, if you think about hemophilia, right, that's a disease that tends to affect black people more often than white people, and so when they figured that out is when they did statistics and ran and said that this was more common in black people than it was for white. And so they said, hey, you guys need to worry about it more and look for it more frequently and make sure that you have a higher red blood cell count so that you don't run into hemophilia. Right? That was a study that was done back in the early 1800s to discover that, right? right? And they wouldn't have if they hadn't kept track of the color of the person's skin, even though you would like to think it doesn't matter. It still does, so that you can subdivide and find problems that might exist. So I'm not saying that race is something that you should always gather, but it may be important sometime in the future, and so you probably should. All right. So, anyways, that being aside, you need to be able to categorize your data. All right. So data tends to come in 4 levels. At least according to statistics. Okay. So statisticians came up with this sort of generic way of subdividing data. So, the most basic type of statistics you gather is called a nominal statistic. A nominal statistic is categorical data. So in other words, there's a category of things that you can choose, and those categories are completely unrelated, right? So, religion, eye color, hair color, all of those sorts of things are nominal because there are different answers that you can choose from, and they are not related in any way, shape, or form. And they are also very much so non-numeric. Okay, so nominal data is data that's not numbers, and the key is realizing that those things are relatively important. All right. Second level of data, and I'm starting on the lowest level data and working up to the highest, so just so you know. Numbers would mean that anyways. Ordinal data. This is also categorical data. But it has comparative value. So, what sorts of categories out there have a comparative value? So think about the surveys you've ever taken in your life. Can you think of anything that was ever ordinal, where you had to choose from a category of like 5 different choices, and one choice was, say, comparable to one of the other choices, but it was still a category? Income, but that's numerical. This is to be non-numerical numbers, though. So it's non-numerical is the key.
How about education level?
Education level, I think that works, right? So we could say high school, college, associates, 4-year. That works. That actually fits. Not in the way I was thinking, but it actually does work. Mostly. I was thinking of something a little bit more generic. Right. How was your experience in class? Was it very bad, bad, average, good, very good? So these are all category items that you're selecting. They're non-numeric. There's no numbers there whatsoever, but they're definitely comparable, right? Bad is worse than average, and good is better than average, etc. All right? Yes, the sort of strongly agree, mildly agree, sort of disagree. But if you've taken any political surveys in the last year, which I'd be surprised if any of you have been able to avoid it, you've had that one, okay? So, I have actually a home phone in my house right now. It's just, we had taken it out originally, and then in order to get some services from Charter up in Madison, I had to get a home phone, and now that phone, good lord. Once they figure out that you have a landlocked line, holy crap, I get called for surveys every night. And the cool thing about it is that the phone I have that it's connected to is hardwired into the wall, and it's a rotary phone. It's one of those turn dial phones that I have in my basement that was in the house when we bought it. And so it's hardwired into the wall. And it actually rings. It's hilarious. I love it. I love calling people on it. I like dial the number and it goes beep. It actually goes beep 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 as you dial it. It's hilarious. But anyway, sorry, it's an aside. But yeah, I mean, it's one of those things where I get surveys all the time, and I'm just like, oh, I've gotten to the point now where I don't answer the phone anymore. Unless I'm ready to answer a 15-minute survey about the next election that's coming up or whatever, all right? So anyways, ordinal data, it's categorical data, but it is comparative. And then the idea is that you can kind of use the comparison to say things about your data. All right, so then it starts to get into the semi-weird sort of stuff. I mean, it doesn't, whatever, but I'll try to explain it. These are tough to differentiate, but bear with me. So interval data is one of the next pieces of information that you can get. And this is now numerical. So the information you're gathering here are numbers. It has a numeric value to it. Notice that data levels 1 and 2 are both categorical, so they're not numbers. It can look like numbers because often they'll say, you know, really bad is 1, bad is 2, average is 3, good is 4, and really good is 5. And those look like numbers, but they're really just categories, okay? So be careful of those. That tends to be a standard trick question in statistics, is that you're given 5 categories numbered 1 through 5 and have those types of terms, and you're asked what type of data it is. Don't be tricked. That is not interval. It's categorical. Even though there's numbers there, the good, bad, average is always categorical. Okay? It's not numerical. Now, interval data is numerical data where 0 does not represent the lack of existence of the value. That's the Webster's Dictionary definition of interval. What does that mean? Well, the idea is, think about the temperature outside. What's the temperature right now? Yeah, like 25, 26, 28 degrees. A couple of weeks ago, the temperature was 0 degrees, right? And even less than 0 degrees. When the temperature is 0 degrees, does that mean that there is no temperature outside? No, it just means it's damn cold, right? So at that stage, 0 does not represent the non-existence of temperature, right? That is why temperature as a data element is an interval data element. It's a numeric, it's a number. The temperature is always going to be some number, right? But when you say that it's 0 degrees, you're not saying that there is no temperature outside, okay?
So does that mean 4 is absolute?
Essentially, or they call it ratio, but essentially yes. That's the sort of thing where 0 means you have nothing. So like income, when you're gathering income data, if you have 0 income, does that mean you have no income? Yes. That is the next level. Okay, that's the 4th level. So here, the classic example is temperature. All right, so and then the last one, ratio, and again, this is all it is the opposite of what the one above it is for interval, right? Again, it is numerical data where 0 does represent the lack of existence of the value. of the statistical value that you're calculating. All right, so income, dollar amount in your pocket, you know, money in your wallet, those sorts of things. You know, what's your GPA? GPA is actually a good one that represents that's interval, right? Because if you have a 0 GPA, does that mean you have no GPA? No, that just means you've done really bad. Hopefully that's not true of any of you, please, right? All right, so again, those are the two numerical representations of data, and then there's two sort of non-numerical representations of data. And the way it works, folks, is that when you're trying to determine whether or not your data is one of these 4 categories, you start at the highest, and if it's not a ratio, you move to the next one and say, if it's not a ratio, is it interval? If it's not interval, is it ordinal? If it's not ordinal, then by default, it is nominal, okay? That's the analysis that you do to determine what level you are on. So, to determine your level of data, start at the highest level and go down until there's only one I in until you reach a true description. All right? In other words, you're looking to make the level of your data as high as possible, and if it's not that, then you have to fall back to the earlier one, and that by default, nominal data is what everything is if it's not one of the other 3, okay? Not bad? Again, this is again more like the idea of setting up definitions, because very rarely do you talk much about these things other than at the very beginning of a statistical paper. You start saying, well, my data is going to be composed of 3 nominal pieces of information and 4 ratio pieces of information. You'll describe each one of those things and then start talking about what you tried to compare between the 7 different categories you gathered. That's the idea. Again, you got to set the paper up at the beginning to make sure it works, and if you don't know those things, then people will not pay attention to you. All right? So, data that is category 3 or 4 is called quantitative data. And that should make sense, right? Because in levels 3 and 4, the data is numeric, so it should be quantitative. Data that is not numerical is called qualitative data. So again, it's the sort of thing that you're categorizing things so that you can make sure you describe them correctly. So again, if you're gathering data and you gather 3 qualitative pieces of information and 5 quantitative pieces of information, again, you're telling the people, I'm gathering 5 pieces of information that are numbers, 3 that are not. All right? Learn to speak the correct language. All right, and then one last piece of thing about your data. When you gather quantitative data, you can categorize it as either being continuous or discrete. Continuous data basically means that you will allow any number of decimal points in your answer or in your data, okay? So if you're getting on a scale to get weighed and the data is telling you that you're 28.45384762222159 kilograms, your data is more likely continuous. If, when you gather this information, you round all of your data to the nearest kilogram, so if you say that the people I weighed are only in intervals of 1 kilogram, you have now made that data discrete, okay? So money, folks, is generally considered, I consider it to be a discrete data value because you go down to the nearest cent and then you stop, right? So there, you either make $30,000.20 or you make $30,000.21. You don't make $30,000.20.5, right? That doesn't make a whole lot of sense. You could try and do that when you calculate an average, but that doesn't make sense when you're gathering the data. And so a lot of times things that have a fixed number of decimals are considered to be fixed. All right?
So discrete like sig dig.
Essentially along those lines. So if you fix a certain number of significant digits, that would often be called discrete. Whereas if you say, I don't care about them, that's all right, so those are nitpicky points, but they are things that you need to be able to do, and they're questions on the homework, so you're going to have to do it. All right? Any questions about this? It should be relatively straightforward, but again, it's sort of throwing a lot at you in a little bit of time. And that is the end of section 1.2. What does that mean?
Dishing it out.
Well, we need to get through chapter 1 this week, so we kind of have to get through the whole chapter. Then we can call it a day. That's the plan. Finish chapter 1.
We'll allow it.
All right, so section 1.3. Studies of a statistical nature. Basically, there are studies that you can do which don't involve statistics, but those are kind of silly because then there's really no point doing them. But that's just me. So, in other words, how do these sorts of things, how do you come about with finding something that you can study statistically? What do you do? So what's the first thing that you think you would have to do? Find something that interests you. Okay, so what interests you, Lindsay? Right, Lindsay? Okay, good. So what interests you, Lindsay? Animals. Okay, now, can I just do a study on animals? You got to fine tune it a little bit. Okay, so what about an animal do you want to know that you couldn't just go ahead and get by grabbing a dog and analyzing it right in front of you? What do you want to know about animals. Well, so, I mean, but that's the idea behind this, folks, is that you need to come up with something that can drive your interest. I mean, being interested in it makes it way, way, way the hell better. When you have to do statistics on stuff you don't care about, folks, it's a pain in the ass, let me tell you. Okay? I've done a lot of statistical analyses on things that I just could not care less about. It's just pain, right? So if you can find something you care about, great. But now you have to start thinking, what do I want to know?
Rate among certain species.
What was that? Sorry, speak up.
Oh, death rate for a certain species.
What do you mean by death rate? As in like average age when they die or something like that?
Sure.
Okay, there's a very good thing that you may want to do. What is the average lifespan of, Lindsay, what animal do you want to study?
Giraffe.
Of giraffes. So the first thing you have to come up with is a question that you want answered, okay? And it's not something that you can just, calculate. So don't ask the question, what is 7 plus 6? The answer to that, folks, is always going to be 13 no matter what statistics you do, okay? So you have to come up with a question that requires analysis and that you can't just find, or perhaps you don't believe the data that's out there already, and so you want to be able to calculate it yourself. All right, so it could be, for me, that the statistic I'd like to know is, how long does it take a student to graduate from Black Hawk Technical College? From start date to end date, on average. And then I can start doing analysis that says, well, for a student who takes, say, less than 3 years, what do I know about them? If it takes them longer than 4 years, what do I know about them? Then you can start fine-tuning your statistics. All right? So these are the sorts of things that you should look at. When you're in a work situation, you want to try and find questions that you need to ask like that. Okay? So, or, what is average time it takes a student to get a degree in UTC? That's the sort of question I would do statistics on. Because I want to know, how long are you guys here? I mean, if it takes you 4 or 5 years, I'd like to know, because then I will try and potentially create a little bit stronger relationships for students because I know they're going to be around here longer. But if everybody is out of here in a year, then for me as a general education instructor, I'm probably more like, okay, I just got to turn the crank and get you out of here because that's what you guys want. Okay? And so that's the way I will approach it. That's the sort of stuff that I would want to know, and so you should look for that kind of stuff to study in your own workplace right now, if where you work is someplace that you actually like. It's really easy to calculate statistics and do it on things that you like. It really is. I have so much statistics about the school from my own experience stacked away in my computer that it's insane. Right? And every now and then when I've got time, I'll sit down and start running programs on it to see what's going on. Right? Usually I compare how the success rates are in my class, and I try and compare. I teach a class, when I teach it the same way for 2 straight years. And then after 2 years, I redo the whole curriculum and make changes wherever I feel like I should. And then I can say, well, I've got 2 years of data. Then I gather 2 years of data and say which one was better. And based on that 2 years of data, whichever one was better for the students, I work off of that one and then redesign the curriculum again. And then say, okay, look at 2 years worth of data compared to the other 2 years of data that I had. Which one's better? Based on whichever of the 3 is better, that's the one I start with. Design new curriculum from that. And so I have this constantly growing statistical analysis all the time. That's the sort of stuff you want to be able to do. If you really want to start getting into statistics, is try and do that kind of stuff. It does take some time, though. All right? If you want to do it for yourself. If you want to work off of other people's data, then it's not as painful like that. But I've been planning this from day one, right? And that's kind of a little bit of what statistics is about, is being ready, having data, all right? So what do you do after you start figuring out your question? Before you quite go that far, whatever your question is, determine what the population is. Okay, so you really want to start by saying, here's my question, now what's the population I'm going to work with? So for Lindsay, when she's worried about giraffes, she may say, I am only going to study giraffes that are in, say, North American zoos. And that may be what your study is. Or you could say, I want this to be all giraffes, in which case then you have to have giraffes from zoos and then giraffes in the wild. And you have to find all the places where there's information on giraffes in the wild as well as being in captivity, right? You have to determine that because that drives how you're going to gather your data, right? So for me, when I'm gathering data, my data is very confined to just me. My population is my classes. I don't worry about anybody else's classes when I'm doing my statistics individually because I've set my population to be my class. Even though other people are teaching the same classes as I am, and we maybe have very similar curriculum, I still only work off of mine. I compare it, I'll give it to my coworkers and say, hey, I've rewritten stuff a little bit to be like this, what do you think? And they'll say like, oh yeah, that's fine, whatever. But that's my population, right? I am setting my own. You have to decide for yourself. Again, it can be problematic sometimes to figure out the population, sometimes it's really obvious right away, right? So if I was trying to figure out what the average time it takes for a student to get a degree in BTC, my population is pretty easy, right? Students at BTC. Done, right? Again, though, just bear that in mind. All right, now, gather data. Okay. Since once you know where you're going and what you want to describe, you collect the data.
So it's pretty much like a science experiment.
Oh yeah. Oh no, it's absolutely a science experiment. Absolutely a science experiment. It's essentially the same thing. It's just that this is usually done about a social setting as opposed to a physical setting. What do you do once you've gathered your data? Calculate statistics, or as we said, analyze it, right? Again, note we are calculating statistics because we're working off of a sample. We are not calculating parameters. These are descriptive statistics, not inferential statistics. Because what's the last step? We've got our sample information, but what do we care about? Well, we care about the population. Our statistics only tell us about one small subset of the population. So our last step is infer population parameters. Basically, take your sample data and tell us what it means about what you think the population is going to be. All right? And I kind of have to dance around this because a lot of the way you describe populations is different based on the type of analysis you're doing. And until you get through chapters 6, 7, 8, and 9, you don't know what those are yet, but I still need to just describe them to you a little bit so that you get an idea. Enough said. Just realize that's our end goal, is to say something about the population because of our sample. All right? That's what statistics is all about. When they tell you that 52% of Wisconsinites voted for Donald Trump, they actually don't know what percentage of people voted for Donald Trump in the state. They don't actually calculate it. What they're doing often the times when they talk about that data is they're sampling people who have walked out of the polling places and asking them, who did you vote for? And then based off of the 2,000 or 3,000 people they ask, they say that's the population parameter. Because technically it's against the law for a news agency to actually go and literally look at all of the population data. It's against the law. We don't really get to know. So it's part of the world, alright? Alright, so okay, so before I move forward, I will give you a little bit of a public service warning. So one of the examples I like to use often is to talk about what a person's GPA here is at VTC compared to their age. All right? So I say, is it true that the older you are, the wiser you are? And because you're wiser, you will get better grades. Wouldn't necessarily be a bad thing to assume is true, right? I mean, if you've been around longer, you probably know how to study, you know how to work, you know how to balance your life a little bit better. You probably have had a little bit of experience about what you're taught, what you're studying, so you'll be more connected to it. More than likely, you should have a GPA that's higher. So does that mean that if there's an older student who comes into class, they should get a better grade? Good. All right. Just because data may imply things are correlated does not mean they are connected. And the other term that you can use instead of connected is causation. Causal is the right word. In other words, just because you're older, it doesn't mean you're automatically going to get higher grades. So there's a relationship in that you can say, on average, the older you are, the higher GPA you have, but it is not a definition going the other direction that says, if you are older, you will get better grades. Cause versus effect, right? Correlated, they happen together, versus they make that happen, okay? That's one of the program teachers here is really big on correlation versus causation, right? Just because two things are correlated, meaning that they're related, doesn't mean that they're causal, as in that one makes the other occur, okay? So, again, just be careful with that, all right? All right, so, in simple terms, correlation does not mean causation. Again, every time we have a statistical study done here at Blackhawk, this program person always stands up and says, you do realize that just because these two pieces of information are correlated does not mean that they are causal in any nature. I've been here for 10 years and I've heard that every time I've had a statistic reported to me at the Blackhawk level. It's a broken record. It's an important broken record, but once you've heard it, you don't need to hear it again. Alright, so that's how you want to go about doing it. So now the big kicker, here's the big kicker. How do we get our sample data? How do you guys think we should gather data? For any of these things.
Well, technically, couldn't you just look at how many people, like, within the school, they can show you how many kids graduated?
Right. Okay, but Is that gonna be enough to tell me everything about the graduation time? Should I just look at 1 year? Should I look at 2 years? Should I look at 3 years?
You probably wanna do multiple years, because it depends on, like, generation too.
Uh-huh.
So like, it depends, so you probably wanna do at least like a 10-year span.
10-year span. Should I gather everybody's information?
You can probably do by graduation per semester.
Graduation per semester, the numbers that are graduating, when did they start, and then use that. What about those people that show up to Blackhawk Tech but never intend to graduate? Should I ignore them?
Technically, they're not getting a degree through Blackhawk Tech then.
Right. So should I ignore them? I mean, they've been here for 10 years. The data would say that they've been here for 10 years and don't have a degree yet. Should I take that into account?
Not getting a degree.
Yeah.
You're looking for people who are start to finish get degrees.
Yeah. So no, because if they don't have a degree, then they weren't really here.
Well, that's what your data's looking for.
Exactly. So this is why you have to be careful describing the population that you're working with, right? Sure seemed like that was a really obvious thing to do, but then there's all these other things that are going on at school that may not necessarily mean that you're getting. So now you're going to have to pick and choose your data, right? So you're going to have to say, well, I'm only going to grab the students who graduated. Is that a good reflection of the whole population of Blackhawk Technical College?
Well, because we do a lot of small program stuff where it's like, you don't get a degree, you get
Maybe
certificates
diplomas or certificates, exactly. So should I include that in my study, or should I differentiate it? I need to potentially go back to the beginning of my problem and redefine what I really want to get and say, do I care about diplomas versus certificates versus associate's degrees? I mean, these are the sorts of things that once you start gathering the data and determining what your sample is, you may have to go back, right? So what I like to do is point out to students that it's okay if once you are even gathering your data, that you can go back and redefine what your parameter is or what your population is, because you've discovered, oops, I didn't think about it enough, and once you started gathering data, you realize I need to be more specific, okay? Which is why this is a good problem to talk about and think about, even though, is it a good thing to really care about? I don't know. All right, so that's information where we can get everything, all right? So let's suppose we want to do Lindsay's giraffe problem. Are we going to be able to sample every giraffe on the planet? No. So how are we going to pick which giraffes we measure? I mean, how are we going to decide which zoos to look at, or what states to look at, or which continents even to look at, right? How do we define that? You better define it, because people will ask if you actually write a paper about it, or discuss it with anybody, really. They'll want to know, well, are your giraffes from Africa? Are they from South America? Are they in American zoos? Are they in European zoos? Are they in East Asian zoos, right? I mean, they'll want to know.
You can always be more specific, saying like giraffes born in the exhibit or whatever, born there, so you can track them from birth to death.
Okay, so how are we going to sample those giraffes? Should we, again, can we sample them all?
Well, you could, because they don't usually churn data because of that.
So should we use the data for every giraffe that was ever born in captivity, going all the way back into the 1950s?
No.
Or should we just like go to the 70s? Should we only use giraffes that are alive right now?
Well, it just depends on what you're
I absolutely agree, definitely. What you're looking for is often going to drive how you gather your data to some degree, okay? Be careful with that though, because this is where you start going down the line of biasing yourself before you even start going. If you're trying to show that giraffes live longer than in the wild than they do in captivity, a lot of times you tell yourself, well, I'm going to go get a random sample. But what you really wind up doing is saying, well, that random sample is going to be really specifically random. I'm only going to grab the giraffes that I know have been dying in captivity and use their data and compare it to the 8 giraffes that I know about in Africa that have lived until they're 48. Is that a good study to report on? It could be, if you're getting paid to do it, from a giraffe foundation, right? So if you're the Republican National Committee and you want to report a statistical analysis that says that the Republicans will always win, who do you ask who you're going to vote for? If you want to make sure that the answer is Republicans are going to get voted, you will ask more Republicans than Democrats. Is that a good way of doing a sampling of data? No. So okay, so how should we really gather data, folks? How should you do it so that it's fair, quote unquote?
Taking multiples from multiple years.
Yeah, and it should be random. Your data had better be random. This is the number one thing that everybody asks about data gathering is, or you should, anytime you see a statistic, you should ask, where'd you get your data, right? So if you watch a specific news channel that is only catering to a specific environment, more than likely whenever they report statistics, they have purchased a statistician who is only going to sample the people that give the result that they're looking for. Okay, those are not real statistical reports because they haven't really gotten a random sample. They'll say, oh, well I did, I grabbed a random sample of Democrats and asked them if they were going to vote Democrat. Oh. Right? I mean, that's silly, right? Duh, you wouldn't do that sort of thing. But do you think that that sort of thing happens?
Yeah, sadly, all the time is the right answer.
I don't, yeah, that doesn't make me happy. But the idea is that you want to gather random data. Random data. All right, so terminology, another term that in theory you should know, but I'll never ask you about. But you may get this thrown at you, is the sampling frame. The sampling frame is just basically, this is the list of possible samples we can select from. So if we were gathering data about Wisconsin, the sampling frame may be all of the counties in Wisconsin. And so the frame would be that each county subdivides Wisconsin into a finite, smaller subset of sampling frames that we can then get information from. All right? Or the cities of Wisconsin may be a sampling frame that we can choose data from. Okay? And you need to, when you were describing how you gathered your data, where you went to gather it from, and you may set that up by telling people the framework that you used to get the data. So you may say, I set up the framework to be the counties of Wisconsin. And now the question is, how did you grab a random piece of information or random data from those counties? How did you do it? What's your technique to get random data from each county? How do you think you go about getting information from each county in Wisconsin? Survey is one way to go about doing it. How else might you do it? How would you pick who to survey, though?
Just random things.
Randomly picking names. Okay, so that's one way of going about doing it, is to grab random. Now, one way of doing it, all right, so how do we start, how do we actually start going? How do we start sampling? Sampling, if I could write. Start sampling. Well, you could, if you wanted to, make your life a living hell and do what's called gathering data using a census technique. A census technique means you ask everybody in every framework. So in other words, you are going to somehow have to go to every county in Wisconsin and ask every person who's in every county all of the information that you want to know. And you have to get it from all of them before you can start doing any kind of a calculation.
By the time you do that, someone will live in it.
Yeah, it's a continually roving problem that you can never solve, right? So usually this is not wise, right? Gather data from entire population. If you can do this, folks, and this is actually the best way to do a sampling, is to get data from everybody, it's just usually unreasonable to think you can even do it, okay? So it is doable though in theory, right? And supposedly every 10 years, that's what our country does, right? 2020 is when the next census is going to happen, and supposedly the government is going to gather information on every person in the country, in theory. They've already built statistics to take care of that, because they know not everybody responds to the surveys, but they try, in theory. Another technique is just calling it straight random sampling. And instead of calling phone numbers, the idea here is pick IDs from a hat. So say you're going to sample 100 people from every county, and so you'll pick 100 social security numbers that you know live in that county, and those are the people that you're going to ask. Even that can be problematic because it's tough to get in touch with everybody, but that's an idea behind it, where it's truly just grab numbers and don't even worry about it. All right? Why might this be a bad way of doing it? Can you see potentially grabbing data that's not truly random by doing this?
I mean, by definition, no.
Well,
But if your sample's not big enough, you're gonna wind up with the wrong group for a true representation.
You're on the right track, yeah. So this sort of random sampling is based on the fact that it assumes we as human beings randomly settle in a specific county.
So you're getting a lot of families in the same type of thinking.
Uh-huh. And if you ask more than one people in the same area of a particular county, i.e. a big city in the county, you are going to get data that's not truly random because you may not actually get some of the people that are in the rural settings. Right? So the reason that this isn't always random is just because we as human beings are not random. And so even though you grab random numbers, the way you've grabbed them may have directly led into picking a specifically biased set of people. Okay? So just be careful. It sounds like you're doing a good thing by grabbing random numbers out of a hat, but it doesn't necessarily work. Okay? Might be bad because humans do not exist randomly. And so it may be a better idea to literally go through the district and say, well, I'm going to grab one person every 5 miles and use that to generate my sample, which might be a better way of doing it. So you can have things called stratified samplings. And this is the idea where you basically say, okay, I'm going to go through each county. Instead of grabbing 100 random numbers, I'm going to say, okay, I'm going to subdivide this county into 100 grids geographically and grab one person out of each one of those geographic grids to find the truly random sample, right? So subdivide your frames by some method like geographic to try to force randomly, to try to get Again, the idea here is that you want your data to truly be random, to be representative of the entire population that you're trying to talk about. So if you're trying to talk about the state of Wisconsin, how do you get a truly random set of data from Wisconsin? Right? And it's not easy. You can't just pick numbers out of a telephone book because there's more telephones in the cities than there are in the rural. So that doesn't necessarily guarantee it, right? So, other methods. cluster method. This one is actually built into us already, right? If your data is already in a forced cluster, pick randomly inside of each cluster. And again, the idea behind all of these is attempts to get random. And none of these are perfect, folks. None of them. Because it's tough to get a true random sample that's really representative. So, one of the other ones is called systematic. Systematic is where you basically say, okay, I'm going to grab a certain number of samples, but I'm going to grab them using the entire population list, and then grabbing an interval of people on the list that you have. So if you know that there are 25,000 people in Dane County, okay, 250,000 people or whatever it is, you're going to say, I want to grab 100 people from there, grab the 100th person, then grab the 1,000th person, then grab the 2,000th person, then grab the 3,000th person, and use that method, that sort of numerical method of counting from each number to the next to determine that it's, hopefully that will be more random. Okay, every nth person from the population until you choose enough. So if there's 20-some million people in the state of Wisconsin and you want to sample 1,000 of them, grab the big list of 20,000 of them and say, I'm going to pick evenly divided by 1,000, whatever that, 20 million. So every 2 millionth person, grab another one. All right? Again, that can also have problems built into it because just because you're grabbing the 20 millionth person, you may not be able to reach them, and then your data starts to break down. And then the last method is called the convenience method. This is the survey method. So if you want to get in theory, random sampling, send out a survey to everybody in the state of Wisconsin with a 5-question survey on it and say, please send this back to me by filling it out. Right? Maybe you even self-stamp the return address on the little survey saying, send it to me. Right? Send survey to entire population. And use responses. That's a great way to do it, to do sampling, right? I mean, it's the classic way of doing it, right? It's kind of the way most samples are done, right? You send out this mass mailing, and then you get 200 or 300 coming back, and they're going to be random, right?
You're automatically selecting the people likely to fill out surveys.
Yes, absolutely. In addition, you are also likely to be getting people who actually care about the topic, by definition. You are not going to fill out a survey that's asking you something that you don't give 2 craps of a nickel about, okay? So if you actually care about the topic, you'll fill out a survey, right? This is by far one of the worst ways to gather data, by using a survey. A self-selecting survey, okay? If you have you are forced to fill it out survey, that's a little bit better. But when you're sending out a mass mailing, is there any way that you can force people to fill it out? Yeah, well, probably not, all right? All right, so those are sort of the 6 standard methods that statisticians use to gather data in the attempts to be random. All right. The sad thing about it is that none of those are perfect. None of those are even necessarily the best way of doing it. It's really just a matter of which one of them is the most random that you can actually perform. And a lot of times when it comes down to it, it's based on money, and if you don't have enough money, you can't afford to do these things. All right? All right, and that is the end of section 1.3. And all that I really care about in chapter 1. There is a 1.4 section that talks about how you actually fill out a statistical survey for the, 4 boards of statistical analysis. So like the American Medical Association has a way that you can fill out a statistical study for them. And there's a really big, huge process to go through it. Section 1.4 talks about that, which we don't have to worry about. All right, so for next week, please, folks, do the homework from chapter 1. And on Monday, we will go over it and then starting on chapter 2. Good?
Sounds like a plan.
Oh, crap, I went over. Sorry about that. So just stop.
Just hit stop.